friends. Today we would like to discuss the solution of assignment. You know that very well two practice assignments already we have given based on chapter number 2 electric potential. In this chapter up to here we have discussed few very important topics. For example, what do you mean by electric potential, potential due to charge, then equipotential surface. Yesterday we discussed potential due to dipole, potential due to charged spherical cell. Based on these all topics, few questions already given in the form of assignments. So most of students have solved this. So today we'll think about the solution of these all questions. Approximately 15 questions we would like to solve. So just concentration required. So question number 1 from practice assignment number 1. You can see in first assignment, question number 1, here electric field is given. Question number 1, electric field is given, it is E naught J cap. You know that very well. So you target to find potential at point P, or I can say at y is equal to y with respect to y is equal to 0. That's your target. So we have already idea about the potential at Vy, potential at y with respect to 0. So potential at point y with respect to 0. So you know that with respect to 0. So obviously 0 to y E dot dr. Already here E is given 0 to y. E already E naught j cap dr. You have already idea dx I cap plus dy j cap. Next point very empty. J dot I dot product J dot I 0, J dot J it is already 1. So final answer, potential at point y with respect to origin, it is 0 to y E naught dy. You can see E naught dy. So E naught already out of integration. So 0 to y dy. What is the integration of y? Dy, it is y. Lower limit 0, upper limit y. So obviously after setting limit, your answer should be minus E naught y. So this is the methodology for the first question. Very important. We have already solved many questions like this one. So no problem at all. Now we'll move towards the next question number 2. So just concentration required. Question number 2. Here question number 2 already we have discussed about this question. There is a charged particle and there are 2 points A and B. Test charge or charged particle is given here at this point A and its charge 10 raised to minus 8 coulomb. What is the potential at this point A? 600 volt, while potential at point B 0 volt. So you can see 2 points given, already potential already given. We would like to move this 10 raised to minus 8 coulomb charge from point A to B. So what is the change in kinetic energy? Keep in mind here they provide some additional information. Because of this additional information, many students just we can say that misguided, or I can say that get misguided. Why? Because they also provide information in terms of mass like 1 gram, but there is no role of mass at all, because simply we will apply work energy theorem. As per work energy theorem, W is equal to delta K, change in kinetic energy. So delta K is equal to W. But what's the W? W is equal to Q into delta V. You know that. So delta K, what's the Q? Charge. It is given 10 raised to minus 8. Delta V is called potential difference between A and B. So VA minus VB. Charge 10 raised to minus 8. VA 600. VB 0. 600 into 10 raised to minus 8. Here joule. But if you observe options, then you can see that answer already given in the form of erg. It is CGS unit of energy. You know that 1 joule is equal to 10 raised to minus 7 erg. So here to satisfy this 10 raised to minus 7 power, so 10 raised to minus, you can see that 10 raised to 7 plus 7, here we have to think 10 raised to minus 7. So if you remove this 10 raised to minus joule, so it is 1 erg. So here 60 erg is the right answer. and 1 joule is equal to 10 raised to plus 7 erg. There is a mistake. So 1 joule 10 raised to 7 erg. So 1 erg is equal to 10 raised to minus 7 joule. So instead of 10 raised to minus 7 joule, we can put here erg. So now you can see your answer 60 erg. So this is your question number 2. Now we'll think about question number 3. Very interesting for us. You can see question number 3 very handy. So just concentration required. Analyze these all questions. Try to solve again these all questions. These are the very IMP JEE NEET related questions. ये बेसिक लेवल है अपना. इसमें धीरे धीरे कुछ क्वेश्चंस ऐसे हैं जो ऑलरेडी पूछे हुए हैं. थर्ड क्वेश्चन थोड़ा इंटरेस्टिंग है. 4 equal point charges capital Q each are placed in XY plane. Here 4 charges given. So we think about coordinate system XY plane. 0 to, these are the coordinates 0 to. Obviously we can think about 0 to. So this is, you can see that there is a mistake, not 0 to but yes, 0 to. So 0 to, this is your point, first charge A, 0 to. Then second coordinate given 4 to. So 4 2, this is, you can see that B 4 2, 4 in the direction of x axis, 2 in the direction of y axis. Then 4 minus 2. So this is 4 minus 2. And there is, you can see that 0 minus 2. So this is, you can see that CD 0 minus 2. Okay. Now what's the, we can say that your question, the work required to put a fifth charge capital Q at the origin of the coordinate system will be blank. So here 4 charges given and we have to calculate the work done. ये सभी चार जो points है, just concentration required. This one is the, we can say the 4 points. Here capital Q, capital Q, capital Q, capital Q. 4 charges are placed. We have to set up here for fifth charge. This is, you can see the fifth charge. It is also capital Q. So to set up this fifth charge, what is the work done is needed. Once again, work done. So I can write work done W is equal to Q into V. So what do you mean? Suppose this point is O, A, B, C, D. So we would like to find work done particularly for the establishment of this fifth charge, but at this point O. So work done W is equal to charge multiplied by potential V naught. It is called potential at point O. हमें यहाँ पे फिफ्थ चार्ज एस्टैब्लिश करना है, तो वर्क डन फाइंड करने के लिए हमें फिफ्थ पॉइंट का जो पोजीशन है वहां पे पोटेंशियल फाइंड करना पड़ेगा. तो यहाँ पे पोटेंशियल प्रोड्यूस करेगा कौन? तो ऑब्वियसली चार चार्जेस. तो अपन लोग सबसे पहले V नॉट फाइंड करते हैं, सॉरी VO, दैट मींस पोटेंशियल एट पॉइंट O. तो शुरू करते हैं. फर्स्ट ऑफ ऑल पोटेंशियल ड्यू टू फर्स्ट चार्ज. Directly we can write what is the formula of potential due to charge. It is kq by r. So I can write kq upon r. What is this distance? Obviously 2, you can see. So kq by r. पहले मैं actually kq by 2 ही लिख देता हूँ. Plus what is the potential at this point O because of this second charge. So this is the distance. So this distance 2, this distance 4. So what is this distance? It is 2 square plus 4 square. Simply Pythagoras for right angle triangle. So 2 square 4, 4 square 16, 16 plus 4 20, root 20. Root 20, that means, you know that very well, 5 4 ja. So 2 root 5. So we will write here kq by 2 root 5. Similarly here, whatever the potential produced because of this third charge, what is this distance? It is also kq upon 2 root 5. Similarly here, potential due to fourth charge, it is kq upon 2. You can see this distance 2. So finally we can write V naught is equal to kq common. So here 1/2 and here also 1/2. So 1/2 plus 1/2, that means 1 plus here 1 upon 2 root 5, 1 upon 2 root 5. If you think about these 2 points, so 2 by 2 root 5. So obviously 2 to cancel. So kq 1 plus 1 by root 5. This is the potential at point this O. Now we have already obtained the potential. Set up the value here. So Q here capital Q. V naught already we have found. It is K capital Q 1 plus 1 by root 5. So final answer kq square into 1 plus 1 by root 5. This is your answer, you can see. So most IMP you can easily analyze. Very interesting. Here once again you have to find potential. What is the potential at this point O because of these 4 charges? So question number 3 very IMP, no doubt. Your answer already kq square upon, sorry, kq square 1 plus 1 by root 5. Now we think about the fourth question. What is the line integration of electric field along the circumference of circle? Circumference यहाँ से यहाँ तक का ये हमने डिस्कस किया था, याद करो. फंडामेंटल कैरेक्टरिस्टिक्स ऑफ conservative field. In conservative field, whatever the work done required in moving charge from one point to other depends only initial and final position, independent of type of path chosen. And second characteristic, work done required in moving charge along any closed path always equal to 0. So here along any closed path, that means answer 0. So question number 4 of practice session 1, 0. Now fifth number, a moving electron approaches another electron, then what would be the change in the potential energy of the system? Potential energy का formula Q is equal to, sorry, U is equal to W. W is equal to, you know that QV. But already we have idea about potential due to charge. It is KQ by R. तो potential energy का formula होता है K Q1, suppose Q2 कर दो, K Q1 Q2 by R. ये formula हम लोग डिराइव करने वाले हैं. ये क्वेश्चन थोड़ा जिसे कह सकते हैं थोड़ा जल्दी एडवांस में आ गया, मगर ये फॉर्मूला अप्लाई करना है. मगर आप देख सकते हो इसमें जिसे कह सकते हैं कि एनर्जी इज इनवर्सली प्रोपोर्शनल टू डिस्टेंस. अगर दो पार्टिकल्स नजदीक आएंगे सो आर डिक्रीजेस, ऑब्वियसली यू इंक्रीजेस. सो आंसर इंक्रीजेस. Don't worry about this formula. We will derive this formula in the next segment of this chapter number 2. Now question number 6. 2 coulomb electric charge is displaced from point of electric potential minus 20 volt to some other point. The work done is 200 joule. So what is the potential at the second point? तो अपन लोग इसका जरा डिस्कशन शुरू करते हैं. ये क्वेश्चन भी अच्छा, ज़्यादातर ऐसे क्वेश्चन में आप जानते हो एक ही फॉर्मूला अप्लाई होता है. So concentration required. Here 20 coulomb charge is given and you have to move this, sorry, 2 coulomb charge. This is 2 coulomb charge. It is suppose situated at this point A. What is the potential at this point A? Suppose here potential minus 20 volt. It is V1 or I can write VA. Now we would like to move this charge from this point A to B. Here potential no idea. Potential at this point B, it's your target. But whatever the work done is needed, it is 200 joule. So work done 200 joule. So work done is equal to Q into delta V. Charge Q delta V, it is simply VB minus VA. You can see because here you are moving this charge from A to B and another information given or not. Now electric potential at the second point you target. This is potential difference. So what is Q? Q already 2 coulomb. VB, what is the potential at this point B? No idea. What is the potential at point A? Minus 20. So 2 into VB plus 20, but here W already given 200. So if you simplify 200 divided by 2, so answer 100. 100 is equal to VB plus 20. So obviously VB is equal to 80 volt. This is your answer. So potential at point B, here you can see that 80 volt, most IMP, and that's the reason potential at this point B is, you can see that higher than at this point A. So that's why VB minus VA. Important, no doubt. Question number 7. Now the next point, which of the following is not a unit of electric potential? 4 options. Electric potential का unit कौन नहीं है? Number 1 joule per coulomb, volt, W or Newton meter per coulomb. What's the, we can say that point, W in watt, joule per coulomb, volt, watt, Newton meter per coulomb. You can see this is your, we can say 4 options. Which one is not unit of electric potential? Obviously watt is not unit of potential. It is simply the unit of power. So you can see 7 questions from this assignment number 1. Now we'll think about assignment number 2. Okay, so just concentration required. The solution नंबर 2, इसमें भी क्वेश्चंस अच्छे हैं, जस्ट चेक इट। सभी का एक सॉल्यूशन कंटिन्यूस बनाते रहो और एक नोटबुक में कवर करते जाओ। सेकंड सॉल्यूशन नाउ स्टार्ट। ओके, practice session number 2, question number 1 very empty. You can see there is a graph. This is the graph of potential versus displacement r. Check करो ये graph, ऐसा graph. Here your target to find electric field at r is equal to 5 meter. This is distance r. So 0, here 1, sorry, here 1, 2, 3, 4, 5 and 6. This type of section here 1, 2, 3, 4, 5. Okay, so what's your target? Your target to find electric field at r is equal to 5. Here we would like to find electric field here. So we have already idea about the relationship between electric field and potential. E is equal to V by R. But you can see here it is, sorry, here the information is given in the form of graph. So where is we can say the 5. याद करो चैप्टर नंबर 3, ऐसा हमने न्यूमेरिकल सॉल्व किया था। चैप्टर नंबर 3, सिंपली द मोशन इन 1D. I would like to find potential, so electric field at this point 5. Just extend this 5 point. You can see that touches this line. So we have to find simply the slope of this graph. ये पोर्शन का स्लोप फाइंड करना है। स्लोप फाइंड करना हो, so you know that very well, delta V by delta R. So what is the delta V? Initial, final. तो देखो इसको एक्सटेंड करो, सो डेल्टा वी ऑलरेडी विथ यू, ये जो डिस्टेंस है वो होगा 5, ऑब्वियसली हियर 5. व्हाट इज द डेल्टा आर पर्टिकुलरली फॉर दिस पॉइंट 4 to 6, इसको डाउनवर्ड डायरेक्शन में एक्सटेंड करो दिस डिस्टेंस। ना पता चले तो मैंने आपको एक दूसरी मेथड भी सिखाई है, ये रहा आपका ग्राफ, ये ट्रायंगुलर ड्रॉ कर दो, ये डिस्टेंस है 5, ये डिस्टेंस है 4 to 6 यानी 2, देयर इज थीटा. How can you find? By considering tan theta, so 5 by 2. याद करो, या फिर डायरेक्टली इधर 5 by 2. But you can see here slope already negative because here theta more than 90 degree. So that's why negative slope. So answer minus 5 by 2. So it is minus 2.5. Ready? So this is the answer, minus 2.5 volt. Now the question number next. ये भी अच्छा क्वेश्चन था. Don't forget. वेरी इंटरेस्टिंग पॉइंट 2.5. रेडी? और इलेक्ट्रिक फील्ड और पोटेंशियल का एक और मोस्ट इंपोर्टेंट रिलेशनशिप है, वो हम लोग जो नेक्स्ट सीरीज शुरू होने वाली कल से उसमें डिस्कस करने वाले हैं। उसके मुताबिक जाएगा तो इधर आंसर चेंज होगा। क्यों चेंज होगा वो हम लोग कल डिस्कस करेंगे। आंसर इंपोर्टेंट नहीं, मैंने वापस बोल रहा हूँ कि ये मेथोडोलॉजी देखो, आंसर जो है वो सिचुएशन के मुताबिक चेंजेस होते हैं, नो प्रॉब्लम एट ऑल। बट दिस इज सिंपल, वी कैन से दैट एप्लीकेशन ऑफ योर ग्राफिकल मेथड and formula power. Now we will discuss the next one. Second question, ये भी बहुत है कि two metallic spheres, very handy ऐसे questions definitely NEET में आने के चांस पूरे, most important. Two metallic spheres, number 1, number 2, radius R1 and R2. You can see R1, R2, and the next information given, and they both are charged. Now they are brought into contact, like by using metallic wire. Okay, and then they are separated. If the electric fields on their surfaces are E1 and E2, electric fields E1 and E2, then what is the, we can say that E1 by E2. Most IMP from today, ऐसे न्यूमेरिकल्स पूछेंगे most IMP, so be alert. From today, if two spheres or we can say they come in contact, electrical contact and separated, then don't forget after separation one quantity always becomes equal and it is potential. क्योंकि suppose इधर ज्यादा चार्ज होगा तो पोटेंशियल यहाँ ज्यादा होगा, तो always charge will flow from high to low. अगर इधर पोटेंशियल ज्यादा होगा तो चार्ज इधर जाएगा, इधर पोटेंशियल ज्यादा होगा तो चार्ज इधर जाएगा। कब तक चार्ज ट्रांसफर होगा? जब तक दोनों के ऊपर पोटेंशियल सेम ना हो जाए। So after separation obviously V1 is equal to V2. If you observe data, you can see here your answer should be required in the form of radius. This ratio you have to find in the form of R1, R2. ऐसे क्वेश्चन हमने एक डिस्कशन भी किया था, तो अब शुरू करते हैं। V1, what is the potential? इसके ऊपर चार्ज सपोज Q1 है, इसके ऊपर चार्ज Q2 है, तो V1 का फॉर्मूला हम जानते हैं। ओके, चार्ज की वैल्यू दोनों के ऊपर Q1 Q2 दी है, सो KQ1 upon R1 एंड इधर होगा KQ2 upon R2. यू नो दैट पोटेंशियल ड्यू टू चार्ज कैसे फाइंड कर सकते हैं? तो ये स्फीयर है, तो इस चार्ज को अपन लोग सेंटर पे रख सकते हैं, तो सेंटर से सरफेस की दूरी R1, तो ये फॉर्मूला है। मगर अपने को E1 E2 में जाना है, तो हम लोग तो जानते हैं व्हाट इज द फॉर्मूला ऑफ इलेक्ट्रिक फील्ड, इट इज KQ by R2, जबकि इधर R1 ही है, तो अपन थोड़ा मैथमेटिकल सेटिंग करें, R1 square multiply by R1. Similarly here, KQ2 upon R2 square multiply by R2. Now you can see the same story, but what is the KQ1 upon R1 square? It is called electric field on the sphere number 1. So E1 R1. Similarly here, E2 into R2. So what's the final answer? E1 by E2 is equal to obviously R2 by R1. That's your answer. So this ratio is obtained in the form of R2 by R1. If you observe this answer, then you can see very important. तो ये ऐसे क्वेश्चंस खास पूछ सकते हैं, इसमें आपको ऐसा ही प्रॉब्लम अप्लाई करना है। शॉर्टकट्स भी होते हैं, मगर मैं कहता हूँ शॉर्टकट से वो सिचुएशन के मुताबिक चेंज होते जाएंगे, सरफेस चार्ज डेंसिटी आएगा, काफी कुछ पॉइंट्स आएंगे, बट दिस इज द आइडियल मेथड। सो वंस अगेन, टू स्फीयर्स, electrical contact, after removal of electrical contact, then always which quantity becomes equal? It is always potential. यहाँ से न्यूमेरिकल शुरू करना है, V1 is equal to V2. So now we move towards the question number next, third number. The dipole moment of dipole is 4 into 10 raised to minus 9 coulomb meter. Dipole moment, you know that dipole moment, it is denoted by P. So dipole moment given P. Next point, the potential of a point away from 0.2 meter, distance given 0.2 meter, in the direction making angle theta given 60 degree, with axis of dipole is blank. So अपने को फाइंड करना है the potential of a point. What is the formula of potential due to dipole on axial line? और जनरल फॉर्मूला ऑफ पोटेंशियल, जनरल फॉर्मूला याद करो, K P cos theta upon R square. फिर इसके ऊपर से हमने V axial, most important, it is KP upon R square plus or minus. V equatorial, it is 0. So in this equation, K you know that 9 into 10 raised to 9, P already given, theta already given, R already given, all values given. Simplify and you get answer 450 volt. 450 volt answer. Okay, so this is your question number 3. Now question number 4. On each vertices of a square of each side of equal length A, 4 charges are set up, plus Q, minus Q, minus Q. Then what is the potential at the center of square? So very easy, no doubt. वापस बेसिक कंसेप्ट, हमने जो असाइनमेंट दिया है वो आपके बेसिक कंसेप्ट रिलेटेड दिया है। 4 चार्जेस, प्लस Q, माइनस Q, लेंथ ऑफ साइड A. We would like to find potential at the center of square. Okay, so here you know that very well. For square, apply the concept of geometry. Diagonals simply bisect perpendicularly, and this distance simply same. This is A. So what is this distance? It is already √2. A distance होगा total √2A. So √2A. But if you think about only this portion, so divide by 2. So it is A by √2. तो यहाँ से A दूरी A by √2, AB दूरी A by √2, AB A by √2. So start. What is the total potential at the center? First of all, potential due to first charge, it is KQ upon this distance, A by √2. Then plus KQ upon A by √2. Then minus KQ upon A by √2 minus KQ upon A by √2. Now answer just in front of you, you can easily analyze, and if you simplify, then cancellation answer 0. So question number 4, 0. Fifth number, a point P is 25 meter away from a point 1 microcoulomb charge. So we discuss the fifth number. So friends, you can see if you have basic conceptual power and formula power, then these applications always we can say become very easy. So question number next, fifth number. There are two charges, 4 microcoulomb, 1 microcoulomb, and from this 1 microcoulomb at a distance of 25 meter, there is a point You can see the P is situated, and this point P is also situated from 100 at a distance of 100 meter from this 4 microcoulomb. Okay, so what is the electric potential at point P? यहाँ का potential find करना है. So potential at point P is V1 plus V2. इसको Q1 कह देते Q2. V1 यानी KQ1 upon R1. V2 यानी KQ2 upon R2. Now you know that Q1 already 4 microcoulomb. What is the distance? Distance already you can see that 100 meter. Similarly here Q2 1 microcoulomb. What is the distance? 25 meter. Set up the value. Simplify. You will get answer 720 volt. This is very easy. Basically ऐसे questions है वो सिर्फ formula power और basic students के लिए है ताकि वो धीरे धीरे अपना logical power develop कर सके. Now we will discuss the next one. Question number 6 is shown in figure plus Q charge. So we discuss question number 6, 7 and 8. Just concentration required. This is question number 6. Okay, as shown in figure, plus Q charge is carried from point A to B along a semicircular path, like in this way. Here point A, B, यहाँ test charge. So we would like to move this test charge from A to B, but along this semicircular path. But plus Q charge is placed here at the center. There is plus Q charge. This distance R, this distance also. So what is the work done required in moving this charge? Once again, work done W is equal to Q into delta V. Here test charge Q, no doubt. Delta V, that means VA minus VB, potential difference between A to B. It means A and B. So what is the potential at point A? यहाँ पे potential produce करेगा कौन? This is source charge. It is K capital Q upon R. And minus what is the potential at point B because of this plus Q charge? K capital Q upon R. Obviously both points A and B are at same potential, so no potential difference, 0. You can also consider equipotential surface. This surface can be considered as equipotential surface. कोई बोले कैसे? Plus Q को center पर रख के complete circle ड्रॉ करो. तो हमने कल ही बताया था कि चार्ज को सेंटर पर रख के अगर ऐसा स्फेरिकल सरफेस कंसीडर किया जाए तो वो सरफेस इक्विपोटेंशियल सरफेस बन जाए, और इक्विपोटेंशियल सरफेस में पोटेंशियल की वैल्यू रहती है सेम. सो दिस इज क्वेश्चन नंबर 6. नाउ वी डिस्कस 7. 7 नंबर मोस्ट टाइम पे ऐसे क्वेश्चन है वो परफेक्टली पूछेंगे फ्यूचर में, सो बी अलर्ट. शॉर्टकट थ्रू करेंगे. 27 आइडेंटिकल ड्रॉप्स कंबाइन एंड फॉर्म अ लार्ज ड्रॉपलेट. ओके, ये रहा ऐसा एक ड्रॉपलेट है, उसके ऊपर पोटेंशियल V नॉट है. So this type of 27 droplets combined 1 2 dash 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 27 and form this type of large droplet. Then what is the potential on this large droplet? Potential on each droplet V naught V naught V naught. What is the potential on large droplet? तो इधर मैं एक शॉर्टकट लिख रहा हूँ, आज से ये शॉर्टकट दिमाग में रखना है. For n number of droplets, or I can write if n number of droplets combine. Okay, the potential on large droplet or bigger droplet always given by equation V is equal to n raised to 2/3 V naught, where n represent the number of droplets, V naught represent potential on each droplet. Ready? And ऐसे की सिचुएशन में एक और शॉर्टकट दे देता हूँ. What is the radius of large droplet? ऐसा शॉर्टकट मैंने फ्लूइड मैकेनिक्स में दिया था, टर्मिनल वेलोसिटी याद करो. सो रेडियस ऑफ लार्ज ड्रॉपलेट n raised to 1/3 r. n represent number, r represent radius of each droplet. So we'll apply this concept here. So जब शुरू करते सीधा इधर. So v is equal to n raised to 2/3 v naught. n here number of droplets 27. So 27 2/3 v naught. So 27 को इस तरह लिखे क्यूब रूट, पहले क्यूब रूट और उसका स्क्वायर इनटू v naught. क्यूब रूट ऑफ 27 ये ना है तो मैंने कितनी बार बोला है क्या करना है आपको पता है. आईने के सामने खड़े रह के क्या बोलना है. 27 क्यूब रूट 3 स्क्वायर 9. So answer 9 v naught. That's the we can say that answer of this question. Very I am two shortcuts. So ऐसे क्वेश्चन में ऐसे फॉर्मूले धूम मचाएंगे. ऐसे फ्यूचर में बहुत काम में आने वाला है, डैम श्योर। ये जो ट्यूसडे जेडब्ल्यू नीट का टेस्ट है उसमें ऐसा क्वेश्चन होगा ही, सो बी अलर्ट। नाउ वी डिस्कस लास्ट क्वेश्चन 8 number, the radius of nucleus of atom having Z atomic number 50 is given, then what is the electric potential on the surface? So ऐसा कोई अपन लोग एटम कंसीडर करें, उसका रेडियस दिया है, तो हम लोग तो जानते हैं कि चार्ज को हम लोग इधर ले तो सरफेस पे पोटेंशियल का फॉर्मूला है V इज इक्वल टू के क्यू बाय आर। अगर ऐसे न्यूमेरिकल में चार्ज ही हमारे लिए प्रॉब्लमेटिक होगा, सो हाउ कैन यू फाइंड चार्ज? ये लोगों ने देखो बहुत ही स्मार्ट वर्क किया, Z गिवन एटॉमिक नंबर गिव्स आइडिया अबाउट नंबर ऑफ प्रोटॉन्स और नंबर ऑफ इलेक्ट्रॉन्स। मतलब अपने लोगों को Q फाइंड करने के लिए क्वांटाइजेशन ऑफ चार्ज Q इज इक्वल टू NE, सो Q N ऑलरेडी 50, E 1.6 into 10 raised to minus 19, so we can find Q, so we can easily find K 9 into 10 raised to 9, Q already here, R is the radius, it is already given, and radius already here 9 into 10 raised to minus 15 meter. If you simplify, then you will get answer 8 into 10 raised to 6 volt. This is the answer of this question, 8 into 10 raised to 6 volt. तो ये एटॉमिक नंबर वाले न्यूमेरिकल में खास याद रखना, चार्ज बहुत इंपॉर्टेंट रोल प्ले करेगा। सो यू कैन सी इन दिस वे वी हैव डिस्कस्ड 15 क्वेश्चंस, few questions are very important, few questions based on your fundamental conceptual clearance. Friends, अब ये सीरीज जो सेकंड पॉइंट में शुरू होने वाली है, अभी तक हमने इलेक्ट्रिक पोटेंशियल के 7 पार्ट्स देखे, यानी 7 पार्ट्स। ये 7 पार्ट्स इक्विपोटेंशियल सरफेस तक गए हैं। अब जो 8 पार्ट शुरू होने जा रहा है, ये अपना 8 पार्ट नहीं है, ये सॉल्यूशन है। एवरी संडे हम लोग ध्यान रखते हैं कि एवरी संडे जेडब्ल्यू नीट सॉल्यूशन ही होगा, डोंट फॉरगेट। तो ये ट्यूसडे का पेपर भी संडे सॉल्व करेंगे, मंडे अपन लोग जानते हैं कि थ्योरेटिकल न्यूमेरिकल का टेस्ट है। अब सबसे इंपॉर्टेंट पॉइंट है, जितने लेक्चर्स है उसको बार बार रिवाइज करो, कल के एग्जाम के लिए प्रिपेयर करो, जेडब्ल्यू नीट के लिए प्रिपेयर करो। सो कल से यानी कि मंडे से नेक्स्ट लेक्चर से हम लोग यानी पार्ट 8 से बहुत ही इंपॉर्टेंट सेगमेंट शुरू करने जा रहे हैं इस चैप्टर का, जो इस चैप्टर का हार्ट माना जाएगा फ्यूचर कोर्स में। सो बी अलर्ट, बी केयरफुल, स्टे होम, बी सेफ। थैंक यू।